Okay, I'm going to continue here with our little project of writing a basic language computer program that divides two polynomials. In particular, what I want to do is I want to do something like this. I want to take a polynomial of, let's say, arbitrary order n with coefficients an minus 1 all the way down to a0, and I just want to divide it by the linear term b1x plus b0. So I want to do this, and I want to compute the quotient and the remainder of the result. So let me begin by starting to assemble this basic language program in order to do that. So I'll open up my Chipmunk Basic window right here, and I'm going to try to start to write the program. Now, the first challenge we have in the program is how are we going to input these two polynomials? Well, the polynomial is really completely characterized by inputting the coefficients. So I'll input all these A coefficients and then input the two B coefficients. Now, at the moment, I don't know the order of the polynomial that I want to input. So I'm just going to begin by arbitrarily saying, let's say we're not going to have a polynomial larger than a 10th degree polynomial, although it would be easy for us to make it larger. And so I'm going to begin by setting up what's called an array variable to hold the A coefficients. And I'm going to set the size of this array variable. I'm going to say dimension A 10. So this tells the computer how many variables A, how many coefficients A we're going to have. And they're going to be numbered A1, A2, A3, and maximum we're going to take is A10. I could set that to dimension A100, but for right now, just leave it as 10. Okay, now I'm going to have to somehow input what those coefficients are. So let me try that. I'll do statement 20, and I'll say input, okay, open quotation, the degree of the numerator polynomial is space, comma, n. So I'm setting the degree of the numerator polynomial to be n. Now let me list. Okay, so there I have that. And let's run it just to see if it's running right. The degree of the numerator polynomial is, and I'll say 4, and it takes it. Okay, that's all the program has to do. Now I'm going to actually input the values of those coefficients. So I'm going to do that with a for loop. So let me say 30 for I equals 1 to n, and then 40. Now I input the polynomials, but the polynomial coefficients. But you know, when I write down a polynomial, I always start with the highest power term. And the highest power term would be which is backwards of the way I'm setting up the array. I'm setting up the highest power term would be the last term that we write. Let's see. Let me write it out. You've seen me do this before, and see if you understand what I'm doing. Okay, P equals n plus 1 minus I. So this way, when I is equal to 1, P is equal to n. When I is equal to 2, P is equal to n minus 1. So I'm going to be inputting the polynomials starting from the back and working toward the front. And now I'll put in a statement 50. Statement 50 says print the coefficient A parentheses. Now I'll have quotation mark, comma, P, comma, quotation mark, parentheses, is, space, parentheses. Okay, so here's what it's going to do. It's going to print the words, the coefficient A, open parentheses. Then it's going to print the value of P. I want to put a comma here. Okay, so let me back up there. I don't know if this doesn't look like it's going to work here. Comma. Okay. Let me try this again. 50. Print the coefficient A, open parentheses, quotation mark, comma, P, comma, quotation mark, close parentheses, is, space, parentheses. So let me look at this again. It's going to print the coefficient A, then it's going to put the value of P in between the two parentheses. It'll print is, and then, so what it's asking for is input that. So right now I have the coefficient, okay, is. Okay, now put statement 60. Statement 60 says input A of P, A of P, close parentheses, and then 70 will be next I. So let's see if this is running properly to this point. Run. The degree of the polynomial is 3. The coefficient A3 is, and it asks me to input. I'll input 1. Coefficient A2 is 1. Coefficient A3 is 1. Okay, so that's working properly. Gee, space here is too big, so maybe I don't want to put commas there. Maybe I want to type 50. Print the coefficient A, parentheses, quotation, semicolon, P, semicolon, quotation, parentheses, is, space, parentheses. Now type run, say 3, there, that's a little bit better. 1, 3, 3, 3, there. Okay, so that's getting in the coefficients of our third degree polynomial to be 3, 3, 3. Okay, now after I input those, I want to input the values for B1 and B2, so I'll put statement 80, input the two values for B1 and not B2, B0 are parentheses, comma, and then I'll put B1, comma, B0. So it inputs those. Okay. Now, after I input the polynomial, I'm going to want to print it out so I see that I have input the proper polynomial. So let me try this. 90, print the polynomial is space there. And now I'm going to want to print out all the coefficients. Now, I don't know, I haven't quite figured out how I can print them out all on a horizontal line. And so if one of you guys figure this out, let me know. But for now, I'm going to print it out as a vertical column. Okay, for I equals 1 to n 110 p equals n plus 1 minus I, print 120 120 print. I'm going to print the value of p, and I want to print it with x raised to the pth power, then 130 next I, and then 140. I'll print the divisor is now I'll put semicolon B1 semicolon quotation x plus quotation semicolon B0. I hope that's right. Let's see what I'm list. Oh, list. Damn. List. Okay. I have list dimension A10 input degree. Let me try running this. Degree of polynomial is 3, 1, 1, 1. I'll put 1 comma 1. So I think it's got it right here. I have the polynomial is x cubed plus x squared plus x. Let's see. I see this is there's a mistake here in that I'm not inputting the value of the constant. That should be not, if it's a third order polynomial, I should be inputting 4 constants, A3, A2, A1, and A0. So for I equals 1 to n, the polynomial is degree. Okay, so what I actually, my I loop should really go through n plus 1. Okay, you see what I'm talking about? This is, I have A3 is x cubed, A2 is x squared, A1 is x, but this is not giving me the constant in the equation. So I need to have an extra term. For a third degree polynomial, I have to input the constant value. So I need the coefficient for A0 here. Okay, let me think about that, and we'll deal with it next time.